take out 1 or 2 grains, and based on those grains, we decide whether food is properly cooked or not. Therefore, we are using procedures of sampling, representative sampling. Vegetable purchase. Whenever we go to the market, we want to purchase nowadays, of course, it is online, but when we go to the market for purchasing, how do we decide? We check the vegetable from 2-3 hips, and we decide that we are going to buy from this particular hip. Again, we are using the principle of sampling. But sampling, the statistics has been used by the rulers of ancient kingdom all over the world, not for the welfare, but for the state, for the purposes of war and finance. If I go to the term, how it was coined by German scholar Gottfried Kenwald in the middle of 18th century from the Latin word status, which means collection, processing, and use of data by state. Every one of us know the Kautilya, Chanakya, the Arthashastra of Kautilya, where he has listed in elaborate statements that how the data was being collected at that time. Therefore, even in ancient India, we had a foolproof system for collecting the data. In the Mughal period, Ain-e-Akbari is a very important resource. Great compilation of administrative and statistical survey of India under Emperor Akbar. It contains a wealth of information. And if I quote a sample from that, it is average yield of crops for 3 different classes of land. Therefore, land classification was there. Annual records of rates based on yield and price of 50 crops. Therefore, price of crops as well as productivity was a consideration at that time. Extending over 19 years, that is, time series was being maintained. Daily wages of men and employed in the army and navy. Weights of 72 kinds of food. Therefore, all these things were available. Why and how such masses of data were compiled, where these were stored at the time, how it was analyzed, for that nothing is known, but what administrative machinery was used and what precautions were taken to ensure completeness and accuracy is not clear. Today, in our country, we have a Ministry of Statistics and Program Implementation, which is mainly responsible for official statistical system. And for the benefit of the students, we have a National Statistics Day on June 29, which was celebrated first time on June 29, 2007. It's the birthday of Professor Prashant Chandra Mahalanobis, the founder of Indian Statistical Institute, Kolkata, and the main architect of building our planning 5-year plans. Then we have a World Statistics Day on October 20, which was first celebrated on 20th October 2020, and it is celebrated every 5 years. Therefore, 2010, 2015, and 2020, we celebrated World Statistics Day. If I go back to the period of Mahabharata, which is an anecdote which was written by the famous sample survey statistician V.P. Godambe, the paper appeared in 1917, the American Statistician. And this is story, many of you would have heard it, that Nal and Damayanti, when Nal lost whole Hojib empire in the game of dice. And after that, he was wandering in the jungle. The king lost his way in a jungle and was required to spend the night in a tree. He was along with one of his fellow travelers. Next day in the morning, when both of them woke up, he told some fellow traveler that total number of leaves on the tree was so many. Now, on being challenged as to whether he counted all the leaves, he replied, "No, but I counted leaves on a few branches of tree, and I know the science of dice throwing. That is nothing but probability." This is a very simple story, which I'm going to share with you, which tells us that very complex problems have very simple solutions. All of us are aware an unfortunate part of our Indian history, 1947, when there was a partition. A large number of people of minority community took refuge in Red Fort and a small number in the Himayu Tomb. Government had the responsibility to feed these refugees. Task was entrusted to the contractors. In the absence of the knowledge about the number of refugees, the government was forced to accept and pay the amounts claimed by the contractors. Now, the expenditure of the government on this account was very high, and it was suggested that to take care of this high expenditure, statisticians who can count may be asked to find the number of refugees inside the Red Fort. The problem appeared to be difficult under the troubled conditions prevailing at that time, and more complication was that the people who were chosen, they were from the other community than the one which was there in the Red Fort. Therefore, problem was estimate the number of persons inside the Red Fort. What are the constants? Without any prior information about the order of the magnitude of the number, without having any opportunity to look at the concentrations of persons inside the area, and without using any known sampling techniques for estimation of it, nothing can be done. Therefore, what was thought of as a very simple statement that from the bills which contractors have submitted, it was known how much quantity of rice denoted by capital R, how much quantity of pulses denoted by capital P, how much quantity of salt denoted by capital S, denote the quantities of rice, pulse, and salt per day to feed all the refugees. And from our earlier studies or consumption surveys, per capita requirement of these commodities are also known, R, P, and S. Therefore, if I take the ratio of these, they all, if they are true, the number should come out to be same, and that number should depict the number of refugees inside the Red Fort. But when it was done, the ratio quantity of rice to per capita consumption of rice was the largest, followed by pulses to per capita consumption of pulses, and lowest was total salt bill divided by per capita consumption of salt. The basic reason was that rice was costlier, pulses were costlier, therefore their prices were, to raise the bill, their quantity was raised, but salt was a very cheaper price at that time due to Salt India movement. Therefore, this quantity was not enhanced by the contractors. There were discussions, negotiations across the tables, and finally, the number of persons which came to from the ratio of total quantity of the salt bill divided by total per capita requirement of salt was taken as the number of refugees in the Red Fort, and it was paid. Estimated, this estimate helped the government in taking the administrative decisions. The problem was complex, but solution is simple. Therefore, I can go on talking on this. Therefore, I will not be talking. But statistics is recognized as a science when it was included as a section in the British Association for the Advancement of Science, and Royal Statistical Society was founded in 1834. If I quote Sir Francis Galton, the person, famous biometrician, who coined the term regression, he said, and I quote, "I have a great subject, that is statistics, to write upon, but feel keenly my literary incapacity to make it easily intelligible without sacrificing accuracy and thoroughness." Unquote. Therefore, what is the basic question which statistics has to answer? The basic question statistics has to answer is, how statistically significant is the answer? Or what is the probability that this answer could have been obtained by random chance? Therefore, if in one sentence I have to define statistics, it is the science of drawing conclusions under uncertainties. Therefore, this is what statistics is, and there are a lot of applications in different areas of science of statistics. I'll be skipping all those, but again I quote Professor C.R. Rao. If there is a problem to be solved, seek statistical advice. Instead of appointing a committee of experts, statistics can throw more light than the collective wisdom of articulate few. Therefore, statisticians contribute towards the well-being of society in terms of medical statistics. They also work as environmental statisticians for environment risks assessment, fisheries statistics, environmental model assessment, impact assessment, environmental epidemiology, ecology, compliance issues, risk assessment. They also work for the industry, research and development programs. Then in business, then actuarial science is basically a subject which is quite at the interface of statistics and particularly economics. Then we have market research statisticians, which are oriented towards the more or less towards the economics. Then we have government statisticians for having the official statistics in the system. Then statistics can be used in computer science, which we call today as data mining, data compression, speech recognition, vision and image analysis, human and computer interaction, artificial intelligence, stochastic optimization, stochastic algorithms, and so on and so forth. This also includes machine learning, capacity planning, storage and retrieval, quality management, software engineering, performance evaluation, hardware manufacturing. Therefore, it is essential to the field of computer science in ensuring effectiveness, efficiency, reliability, and high quality products for the public life. Generally, it is said that nothing is above law, but there is another statement which is being said that law is not about statistics, because for taking decision in law, many times statistics is being used, particularly in forensic science, particularly taking decision whether there has been a negligence in taking the things to the logical conclusion. In agriculture, statisticians have teamed up with experts in agriculture, which is called agricultural statistics. It is helpful in crop improvement programs, deciding on the package of practices. If we were to stop using chemical pesticides today, which is there is a hue and cry for the environment, how long would it take before groundwater is free of such pesticides? Statistical methods are also being used by hydrologists to predict the effects of changes in the pesticide use. Then today we are using remote sensing data for classification as well as for several estimation problems. And then agricultural statisticians interact daily with the researchers from many sciences to help develop research plans, designing of experiments and surveys, analysis of experimental and survey data, interpretation of findings, and so on and so forth. I can go on talking on this. I'll be skipping all this. Then bioinformatics is also basically an area where statistics helps, but I'll straightway come to a book which I would like that every one of you, whenever have time, kindly read it, by Professor C.R. Rao. The book title is Statistics and Truth. This is a CSIR publication. This is a very good compilation, and every one of us should read. Many of the examples which I was taking, I have taken from this book. Therefore, as I said, statistics is science which deals with collection, presentation, analysis of data, and interpretation of results, and it has two parts: descriptive statistics and statistical inference. Descriptive statistics is collection and presentation and describing a set of data, whereas statistical inference is art of evaluating information to draw reliable inferences about the true value of the phenomenon. Sometimes we believe that statistics is a part of mathematics, but the basic philosophy here, the two disciplines, is altogether different. And statistics is basically an inductive science where we have information on a subset of data. Maybe it is experimental data, maybe it is a survey data, and based on that subset of data, using the principle of inductive inference, we have to infer about the total population. And going from small to large, there may be some errors which are unavoidable. Therefore, descriptive statistics, we have three different measures of descriptive statistics. Descriptive statistics basically presentation of data, and it should not be used for interpretation. Say if I have a data on 474 people on number of years of education, and if I go to that, there are 53 people, I can present them in a frequency table. 53 people have undergone 8 years of education, 190 have undergone 12 years of education. But whatever this table tells, this tells what happened out of 474. But from this, I am not going to infer about the population. If you ask me to present in terms of a graph, I can present in a bar diagram, and you can see again the same information. Frequency table is represented in terms of a bar diagram. Then I can bifurcate the table into subcategories, male and female. If I have to present, I can present in the form of a multiple bar diagram. Then if I want to infer from this descriptive statistics about the population, and let us see what kind of errors we can make. That I want to tell you through a statistical anecdote. The Japanese eat very little fat and suffer fewer heart attacks than the British or the Americans. On the other hand, the French eat a lot of fat and also suffer fewer heart attacks than the British or the Americans. The Japanese drink very little red wine and suffer fewer heart attacks than the British or the Americans. The Italians drink excessive amounts of red wine and also suffer fewer heart attacks than the British or the Americans. Therefore, from these four statements, what do you conclude? Every time heart attacks for British or Americans are more. Therefore, eat, drink, and be merry, whatever you like. It is speaking English that kills you. Therefore, if you infer based on descriptive statistics, we will make this kind of conclusions, and which is not good. Okay. Therefore, there are three measures of data as far as descriptive statistics is concerned. Distribution, through which we can measure the pickedness of curve, that is kurtosis, and whether data is symmetrical or non-symmetrical. If non-symmetrical, it is a positively skewed or negative skewed. Therefore, these are being decided through distribution. Then we have measures of central tendency, which all of you know are mean, median, and mode, and then dispersion, that is measures of variability. Particularly when we talk about measures of central tendency, and if I give you a set of data, first thing normally students do is they found out the arithmetic mean, that is add all the observation and divide by total number of observations. But whether it should be used at every platform or there are some other measures of statistics that should central tendency should be used. Let me take an example to illustrate that from a news article which was published in a national daily around 12 years back. And this article says there is nothing wrong about the numbers in that article. This article says number of persons who are walking on footpath and dying due to accidents is more than the number of persons who are walking in the middle of the road and dying due to accidents. I repeat, number of persons dying due to who are walking on the footpath and dying due to accidents is more than the number of persons who are walking in the middle of the road and dying due to accidents. If I go by this statement, what conclusion I should draw? What conclusion I should draw? Anyone?
We should walk on the road, middle of the road.
We should walk in the middle of the road. But all of us are aware that it is not safe. Therefore, there is something wrong with the presentation. This data should have been presented. Proportion of the people walking on the footpath and dying due to accidents, and proportion of the people walking in the middle of the road and dying due to accidents. That would have made our exposition clear. Therefore, it is while presenting the data, we have to be sure that what measure of statistics we should use for presenting our data so that it does not lead to misleading conclusions. I take another example, which many of us, particularly from North India, must have heard. Lekha Jokha Juka Kyu, Odhi Kumba Duba. This is a story about a statistician who wished to cross a river along with all the family members. Therefore, height of every family member was noted and average height was obtained. He asked his colleagues to take the depth of the river at different places to assure a representative sample. And then average depth of the river was also noted. Average height was more than the average depth. Okay. Therefore, family was asked to cross the river. But on the second bank of the river, statistician found himself alone. Whole family drowned in the river. Okay. Now, calculations were checked and rechecked. Everything was right. Average height was more than average depth. But whole family drowned in the river. The basic reason is that the measure used is wrong. Here, maximum depth of the river and minimum height of the family member should have been taken as the measures. If minimum height is more than maximum depth, then only family could have crossed the river. Therefore, we have to be very careful while using statistical techniques. Otherwise, it will lead to misleading results, inferences, and hence those will not be usable. Therefore, this I'll be skipping through. I will not be talking on this. But generally, people say that a statistician is a person who stands in a bucket of ice water, sticks their head in an oven, and says, on an average, I feel fine. Similarly, there is another example on average, which proves that average is not a good measure every time. And this anecdote involves three specialists, engineer, physicist, and a statistician who goes on moose hunting. After a short walk through marshes, they spotted a huge moose 150 meters away. The engineer raised his gun and fired at the moose. A puff of dust showed that bullet landed 3 meters to the right of the moose, not at the moose. The physicist put his all physics theory into picture, and he noted down that there is a substantial bridge that the engineer did not account for, aimed to the left of the moose and fired. The bullet landed 3 meters to the left of the moose. One bullet 3 meters towards the left, another bullet towards the right. -3 plus 3, 0. Therefore, statistician jumped up, down, and screamed, "We got him! We got him!" Therefore, these are the disadvantages of using average as a measure. Similarly, you know geometric mean, which is nothing but multiply the numbers and take the kth root. This is basically used for taking average of rates of change, ratios, economic index, particularly for this group. If you want to find out average of economic index numbers, it is geometric mean which has to be used and not the arithmetic mean. Similarly, harmonic mean. In harmonic mean, take the reciprocal of the observations, take the mean, and take the reciprocal of the mean. And this is basically used when average cost of some commodities, such as mutual funds, when several different purchases are made by investing the same amount of money each time. Therefore, I can go on talking on this, but let us take these two examples where arithmetic mean is same. Two companies are claiming that they sell fruit juice. Their average fruit juice in a packet is 1 liter. Therefore, to verify the claim, 5 packets were selected at random from company A. 5 packets of company B were selected at random. You can see the figures you are on. An arithmetic mean for both of them was 1. But from which company you would like to purchase the juice? Company A or company B? Now in company A, you see minimum value is 0.94 and maximum is 1.11. And in company B, it is 0.88 and 1.14. Therefore, I am more confident that I am getting a juice of near to 1 liter if I go from company A than company B. Therefore, alone measure of central tendency may not be useful. Therefore, we require measures of variability or measures of dispersion. And these are range. Range is nothing but a maximum value minus minimum value. Quartile deviation, which is which is a difference between third quartile and first quartile. Mean deviation, standard deviation, and variance. And what is variance? From each observation, subtract the mean, take the squares, and take the mean. That is variance. And square root of the variance is standard deviation. And in mean deviation, instead of taking the square of the deviation from any quantity, we take the absolute value. Therefore, these are the measures. But as human beings fight, these measures of statistics are also on fight. And they say, let us see that how we can understand their fight. One day, the variance and the standard deviation were engaged in a heated argument over which was the better measure of variability. We know that both are measure of variability. The standard deviation shouted at the variance, "You are useless because you don't even relate to original score scale." Say if your data is in kg, and if I have the variance, what I'm doing? From each observation, I'm subtracting the mean and taking the square. Therefore, if my original data was in kg, the unit of variance became kg square. That's why this statement. And how do we obtain variance, standard deviation? We take the square root of the variance. And in mathematics, square roots and cube roots and so on forth, they are known as radicates. Therefore, variance, Glad, Back, and Yale, oh yeah, you are totally worthless because you are far too radical. Just then the mean deviation step between the two indices and push them both back. And in a proud voice, the mean deviation proclaimed, you are both wrong. I am absolutely the best measure of variability, since both of you would be worth zero if you did not scare your deviations. In later when, what do statistics professor get when they drink too much? Kurtosis of liver. Similarly, let us take this example. Here, consider the measurement of on yield and plant height of paddy variety. The mean and standard deviation for yield are 50 kg and 10 kg respectively. The mean and standard deviation for plant height are 40 centimeter and 5 centimeter respectively. But now the question is, we have to tell whether the yield or the plant height has the more variability. Now the units are different. I cannot tell anything. Therefore, I need another measure which is unit free, and that unit free measure is known as coefficient of variation, which is obtained by ratio of standard deviation to the mean multiplied by 100. This is percent coefficient of variation. It is a unit free measure. It was computed for both. Now you can see that for yield it is 20%, and for plant height it is 12.5%. Therefore, I can say yield is subject to more variation than the plant height. Therefore, all measures have been defined because there was a requirement to explain, to interpret the data given to us. Similarly, we have percentiles, which divide the data into 100 equal parts, deciles, which divide the data set into 10 equal parts, quartiles, which divided the data into 4 equal parts, and so on and so forth. Then we have probability, which is based on random experiment, random numbers, sample space. I'll not be going through this because then I'll be only talking this. Therefore, there are several probability distributions which are discrete and continuous, and most commonly used distribution is normal distribution. And then we have distribution, sampling distribution, that is T, chi-square, and F, which are basically used for tests of significance and drawing statistically valid conclusions. Then communication is very important. You know that in statistics, there is a term called standard error. But for the statisticians who are working in the government and industry are often faced with language barriers with their bosses. Dr. Stanis Sankar, you want to say something?
Please unmute yourself, Stanisha. Nityashri, you please unmute him. Mute him.
The chief of the statistical office, who was IS officer, was meeting a group of statisticians who complained that in a report received from another organization, some estimates were given without standard errors. The chief could not understand this, and he took it as something what BIS, Bureau of Indian Standards, has, ISI mark. And he asked, are there standards for errors too? Therefore, when we communicate with other sciences, particularly the social sciences, we as the social scientists, when we have to communicate with the other disciplines of sciences, we have to have a basic knowledge of that discipline so that what the researcher from that discipline is telling, we can understand. And also, the person with whom we are communicating should have a basic knowledge of statistics. Therefore, in an information era, statistician will be approached because the client is aware of importance of statistics and of obtaining statistical advice. I can go on doing this, but you can see this later on. The second part of statistics, which I call descriptive statistics and statistical inference. And in statistical inference, again, we have two parts: theory of estimation and testing of hypothesis. Theory of estimation is the estimate of the parameters. What is a parameter? The quantities that represent a particular characteristic of the population, average yield, total production in the country, and so on and so forth, on the basis of sample observation through statistic, a function of sample values which does not involve any parameter. Therefore, this is theory of estimation. And in testing of hypothesis, to compare these parameters among themselves on the basis of observations and their estimates. Now, what is the difference between estimation and testing? Estimation means we are not aware what value is. Given a problem that I want to find out what is the average yield of Pusa 1121 in a particular district. Therefore, what I do, I give this variety to 20 or 40 farmers, get their yield and take an average based on the sampling plan through which I selected the farmers. Therefore, that provides me an estimate of the yield. But if somebody asks that find out whether this particular district yield of Pusa 112 is 60 quintals per hectare or not. Therefore, this becomes, now we know against which number we have to compare. Therefore, now it becomes a problem of testing of hypothesis. Okay, I will not be going into more details on this aspects, but in estimation, again, there are two. Everywhere there are two: statistics 2 parts, statistical inference 2 parts, then estimation 2 parts, point estimation and interval estimation. For a given parameter, if you give only one value, it is a point estimate. If you give the two values between which it is expected that my parameter would lie, it is an interval estimate. Without going into much details, I would like to say that whenever you give point estimate, don't forget to give standard error of the estimate. Without a standard error of the estimate, point estimate is of no use. But as a statistician, I would prefer that you give confidence intervals rather than simple point estimates, particularly with 99% confidence interval or 95% confidence interval, that we are 95% sure that the parameter will lie within these two values. Therefore, there is a difference between estimator is a expression, whereas estimate is a value of that expression for a particular data set. These point estimators have 4 properties through which they are considered. Those are known as unbiasedness, consistency, efficiency, and sufficiency. Therefore, these are 4 properties of point estimators. But again, I would say that point estimate should always be presented along with the standard error. In interval estimate, we present the confidence coefficient. Higher the confidence coefficient, more confident we are that confidence coefficient is nothing but the probability that an interval estimator encloses the population parameter if the estimator is used repeatedly a large number of times. Therefore, we generally talk about 95% confidence and 99% confidence, and confidence intervals are compared with respect to their length, that is maximum value minus the minimum value or upper limit minus lower limit. Therefore, I can go on talking on this, but going to testing of hypothesis problem, as we know that statistical hypothesis is nothing but an assertion or conjecture, either about the form, that is which distribution it is, or about the parameter of the distribution. And again, hypotheses are of 2 types, null and alternative. Null is that under sample study, whatever is happening is result of purely chance. It is noted by H0. And what is desirable attitude of statistician about the hypothesis is termed as alternative hypothesis. It is known as H1. Therefore, again, I have null hypothesis and alternative hypothesis. Now it can be 2-tailed or single-tailed. If my hypothesis is that this is not equal to this is a 2-tailed alternative. And if I have that first is more than this second, or first is less than second, then it is a 1-tailed alternative. And in 1-tailed alternative, again, there are 2, right tail and left tail alternatives. Therefore, I can talk this. Then we have simple and composite hypothesis. Then we have a concept of critical region and probability of critical region. Critical region we have. Then everywhere we have H0 and H1. And I can have 2 decisions, that either I can reject H0 or I do not reject H1. Although here I have written except H1, but strictly speaking, Girish will agree with me that there is nothing like accepting H1. It is not rejection of H0. And please, you may say that I am playing with the English. Do not reject also means accept. but in statistics, do not reject does not mean accept. It only says that from this study, I don't have enough evidence to reject null. Okay. Therefore, in the first quadrant, if I talk, it is reject null when it is true. It is a right decision or a wrong decision? Is it a right decision or a wrong decision? Reject null when it is true.
Sir, it is a wrong decision.
It is a wrong decision. Therefore, this is known as type 1 error. Second, I have reject null when alternative is true. Fine. This is a right decision. Third, do not reject null when null is true. This is also a right decision. And fourth, instead of accept, let me say it is do not reject null when alternative is true. Do not reject null when alternative is true. Again, a type 2 error. Therefore, I have two types of errors. Now, which one is more serious? What is called what? For that, I take an example of Indian judiciary, where a judge who has to decide whether the person has committed the crime. Therefore, till a person is proved guilty, it is assumed that person is innocent. Therefore, my null hypothesis is person is innocent and alternative is person is criminal. Therefore, what is type 1 error? Reject null when null is true. That is, person was innocent, but it is rejected in the judgment. And as a consequence, what happened? An innocent person is found guilty and punished. Second one, do not reject null when alternative is true. That is, person was criminal, but court judgment has said that person is guilty and he was acquitted. Therefore, a guilty person is set free. Now, which one is more serious? Punishing an innocent person or scot-free a guilty person? Normally, the judiciary system says that an innocent person should not be punished. Therefore, type 1 error is more serious than type 2 error. And probability of type 1 error is known as alpha, which you also call as level of significance. And probability of type 2 error is known as beta. And if I take 1 minus probability of type 2 error, it is nothing but power of test. Okay. Therefore, I have to have a testing of hypothesis problem where I can minimize both errors simultaneously. But given a fixed sample size, there is no way that I can minimize both kinds of errors. Therefore, I fix one and try to minimize another. That is, I try to fix the more serious error, that is probability of type 1 error, and try to minimize through test of significance the probability of type 2 error, or maximizing the power of the test, which is 1 minus probability of type 2 error, right? Therefore, this is what we do normally. And finally, if I say that in any testing of hypothesis problem, we have to use these 6 steps: state the null hypothesis, depending upon your objectives of the study, choose an appropriate alternative hypothesis, choose a significance level of size alpha, 5%, 1%, or depending upon the stakes involved in the study, select the appropriate test statistic and establish a critical region, compute the value of test statistic from the sample data, and finally, reject null hypothesis if test statistics has a value in the critical region. Otherwise, do not reject null. And more importantly, give conclusions in terms of the problem to be solved. Therefore, this is the most important aspect, and this has to be seen. Now, here we can see that out of these 6 steps, computer is used only at 1 step. Therefore, basically, basic knowledge of statistics is required. Otherwise, if we use softwares without having a proper knowledge of the problem to be solved and statistical techniques to be used, it will be a garbage in, garbage out. Therefore, softwares are to be used. Yes, they help us in advancing the statistical techniques for proper use, but they have to be used only to avoid drudgery of computation and not as a replacement of subject of statistics or statistician. Using a software without proper knowledge of statistics is like taking a medicine from a pharmacist without consulting a doctor. And we all know those hazards, right? With this, I stop sharing from this part, and I will be sharing another slide of the second part of my talk, and that is data sources and web resources and research data management. Is it visible? Is it visible?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Okay. Now I would like every one of you to note down these 3 web resources. One is design resources server, which is available at https://drs.icr.gov.in. There is another sample survey resources server available at sample.isri.res.in/sample, and statistical computing for NARS available at sscnars.icr.gov. And research data management part you can see on Krishi portal, which is available at https://krishi.icar.gov.in. I would request every one of you to go through these 4 web resources. This I have already talked to you, therefore I can skip. But if I quote again Professor C.R. Rao, who said, all knowledge is in final analysis history, all sciences are in the abstract mathematics, all judgments are in the rational statistics. Therefore, I can go on talking on this, but because this particular course on prediction, therefore statistical models are competitive with those developed by computer scientists and may overlap in concept. Still, classical statistics may be saddled with a timidity that is not up to the speed of modern computers, unquote. But if I say that analysis of a big data and quote Britt Mayo, who said, we view this pile of data as an asset to be learned from. The bigger the pile, the better if you have the tools to analyze it, to synthesize it, and make yourself more and more creative. And there is an International Data Corporation, and if I quote from their report in 2018, they said, the data-driven world will always be on, always tracking, always monitoring, always listening, and always watching, because it will be always learning, unquote. And again, quoting Wilson, American biologist, who wrote 2 books on which he received Pulitzer Prize twice, on human nature in 1979, The Ants in 1991. And he said, we are drowning in information while starving for wisdom. The world henceforth will be run by synthesizers. Who are synthesizers? The people able to put together the right information at right time, think critically about it, and make important choices wisely. And this responsibility lies with all groups of social sciences. If I quote our former Secretary Dare and DG ICR, Dr. Ayappan, he said, statistics like a salt in the food. No one recognizes importance when it is there. Everyone feels its importance when it is not there. But I generally say statistics is not only a salt, it is also a sweet. It has to be taken before, during, and after the. If I can skip through this, if I go to design resources server, this is, I think these 3 resources, let me show you online rather than showing through the PowerPoints. If I go to design resources server, okay, let me again do that. If I go to design resources server, here you can see that there are 2 major parts, useful for experimenters and useful for statisticians. First thing is that this is an international public good. No user ID, no password is required. Everything is available in open access since 2005. When the world has not started even talking about open access. Therefore, everything is available in open access. No user ID, no password, nothing is required. Only a browser is required with an internet connection. If we go to e-learning, electronic books, there are 2. Of course, 2005 standards, they are electronic books, but today we can say online learning material. If I go to electronic book 2, I can see that it is advances in data analytical techniques, and it has 6 modules: computer usage and statistical software packages, basic statistical techniques, diagnostics and remedial measures, application of multiple techniques, modeling and forecasting techniques in agriculture, other useful techniques. Let me click on this. Any lecture you can download, read at user time, session overview, SPSS an overview, SysStat an overview, Minitab an overview, ASRML an overview. If I go to module 2, it is descriptive statistics and exploratory data analysis. probability and sampling distributions, estimation of parameters, testing of hypothesis, test of significance, correlation and regression, concepts and application of linear models, analysis of variance and covariance, all topics on designed experiments, including fundamentals of design of experiments, fundamentals of survey sampling, optimal control sampling plans, variance estimation. If I go to 3, diagnostics and remedial measures, regression diagnostics, outliers, non-parametric tests, particularly for being extensively used by extension specialists, robust regression. Module 4 is multivariate techniques, again, very useful methodology for social scientists, cluster analysis, canonical correlation analysis. Module 5 is mainly for models, and this course will be very useful. Nonlinear statistical models and their applications, time series analysis, fuzzy regression methodology, forecasting techniques in crops, AN and its applications. If I go to module 6, it has variance component estimation, stability, bio plots, bioassays, logit and probit analysis, bioefficacy trials, bioinformatics, design for microarrays, DNA fingerprinting, nanotechnology, statistical techniques for spatial data, and so on and so forth. Therefore, from descriptive statistics to data mining, you can find out lecture notes on anyone. This is particularly with respect to design of experiments. Therefore, I will not be spending much time on this. You can generate online randomized layout of different designs. This you can share with your colleagues. But if I go to this analysis of data, here real life examples are given. And if you have softwares, how to resolve them, that is also given. Therefore, if you have test of significance, these are the, you can download the MS Excel file for your practicals. These are the questions to be answered. If you have SAS available, which is available with our universities, these are the steps to be used. Data file, result file can be downloaded. If you have SPSS, these are the steps to be followed. And if you have Excel, these are the steps to be followed. Therefore, this is given for almost many of the things, which includes PCA, cluster analysis, nonlinear statistical models, and many more things. This particular portion requires more of statistical knowledge. This has more of directly usefulness. Then you have a very good facility here, ask a question. If you have a question, you can raise that question, send an email, gets automatically generated. We try to answer the question if you know the answer to the question, but I don't claim that we know the answer of all the questions. We consult colleagues and library, then answer. And sometimes it becomes a win-win situation that that question requires further research in statistics that we carry out. These are the list of questions which have asked and replied. This is a list of people to whom you can write. Then there are important links. Then books on design of experiments. This is the feedback which we receive. This is how if you have used it, this is how you can quote it in your resources, a research. This is a copyright of ICR and ISRI first, and finally a disclaimer that although every effort has been made, that information provided on this paper is correct and updated, but through the use, if anything wrong happens, Indian Council of Agriculture Research or Indian Agricultural Statistics Research Institute or the developers should not be held responsible. That disclaimer. And if I go to the next resource, that is statistical computing for NAS. Again, this is a where JMP Genomics, SAS Enterprise Guide, eMiner, and for data mining purposes, and SAS is available with all the ICR institutes and SAUs. You can see your nodal officer and from your different institutes and find out how to use it. But more importantly, I want to show you is data analysis using SAS. This is a module that if you have SAS, you can have complete lecture notes are available. SAS for statistical procedures, data sets, simple macros, time series analysis, modeling and forecasting. Then you have fitting of nonlinear statistical models, repeated measures. Then genetics may not be of importance to this group. Enterprise guide, statistical discovery, then eMiner, then SAS Enterprise Guide, JMP, introduction to R. Again, I think the same lecture will be delivered by Dr. Dhanapani tomorrow. IML Studio, macro, learning mechanisms, enterprise business intelligence, and this network solutions. Similarly, I also have enterprise guide, JMP Genomics, data mining using SAS. Here you have examples of data mining, eMiner, pre-processing, ANN, classification, cluster, association rule, self-organizing map, research institution data, time series data mining, and then others. Similarly, you also have here data analysis in social sciences research using SAS. You have here topic analysis, logistic regression, multinomial and ordinal logit models, restriction in regression models, time series forecasting, advanced forecasting model using SAS software. This is a lecture note from none other than the course coordinator for this training program. Crop forecasting based on meteorological data using SAS, multivariate techniques using SAS, multidimensional scaling, demand models, spatial market integration, econometric analysis using panel data, partial equilibrium models, jackknife and bootstrap, all economic and time series procedures, GARCH, structural time series, application of fuzzy regression methodology, functional coefficient of autoregressive non-linear time series for describing India's lack export data, co-integration, and many more. Therefore, you have all this available at your mouse click. They can be downloaded and used. If I go to the third one, that is sample survey resources server, again an international public good. These are all available. This is your e-learning. E-learning, you have e-books on sample surveys, you have e-material, glossary of all terms which are being used in sampling. Therefore, you can find here. And if I go again to this, if I want to see bibliography on different topics, you can find out bibliography. And more importantly, if I go, I have a facility of estimation of population mean sample size when sampling design is simple and I'm sampling without replacement. For the two situations, when population coefficient of variation is unknown and values of a preliminary sample are available from a pilot study, or population coefficient of variation is known. Therefore, if I click on this, it asks me what confidence level I want. Say I want 95% confidence interval. I have a relative error of 5%. I have a population size of 150, say. And it asks me how many observations from a pilot study I have. Say I have 5. Those may be 21, 23, 45, 58. You can see there is a lot amount of variability in the observations. Get answer, therefore very high variability, therefore sample size required is 126. Had this observation be variability is less, automatically sample size will reduce. If it is again less, therefore as the variability decreases, sample size decreases. As the confidence level decreases, sample size further decreases. If I allow this to be 10%, it further reduces. Therefore, it is a sample size is a function of confidence level, desired relative errors which are permitted, population size, and variability in the units. Similarly, you can compute it for when your population variations are known, and for simple random sampling without replacement, you can do it for proportion estimation for both the things. Therefore, this can be done using this, and then this also has several softwares and other things which I will not be talking at this point of time. I would like to show you another resource. That is known from the same resource. I want to show you Indian Math Statistical Computing Portal. But for this, I'm now using Internet Explorer, because this portal is accessible only through Internet Explorer. And here, 24 different analyses can be performed, just uploading your Excel, XLSX, or CSV files, and your output is obtained as RTF or PDF files. If I go to Indian Math Statistical Computing Portal, its user ID for everyone working on IP authenticated machines, that is in the LAN of your institute. Then it is user ID is SSNARS, password is ISRI 2010. Therefore, here, if you see, I have 24 different sample files. These 24 different analysis can be performed without having a software at your desktop, just working with the LAN of your organization descriptive statistics, general distribution fitting, test of significance, chi-square test, correlation, regression, then all designs, principal component analysis, descriptive analysis, then genetic covariance, scientificity. Let me take this file just to demonstrate to you. Save as desktop. I am saving this file. Okay, this file has been saved. And if these are the steps how to prepare your data files, everything is written here. This is how you can use. Therefore, if I use regression, it says that this is how the steps you have to follow. Everything is written. I go to analyze data, select regression analysis, upload the file which I have downloaded, which is an Excel file, COR, open, click on next. Now these are the variable in the data file, NGL, pH, PP, SN, and yield. Therefore, it says enter the names of the variables in the text box below for analysis of variables from variables list shown above. If entering more than one variable name, separate them by a blank space. Select the variable method from the drop-down menu. Therefore, here I give dependent variable as yield and independent variable as plant population, plant height, number of grain leaves. I'm not using anything. Fitting a regression model. Click here and click on finish. This gives me the complete results of the regression analysis. I can download them as RTF or PDF file and write my interpretation and go ahead. If I go again to this analysis and again select this, let me show you again same file I'm selecting. And this time, let me, okay, there are some issues with the server at this moment because you can work on this. I could have done many more things on that. This can be rectified. Okay, therefore, these are the things which I wanted to share with this. Then I also would like to share again the PowerPoint presentation. Therefore, this all aspects I have already discussed with you. Design resources server. I have discussed sample survey resources server. I have discussed Indian NARS statistical computing portal. These are the user ID password. You can write down SSC NARS, and in password it is capital IASRI 2010. Then this is another resource which I would like to discuss with you. ICAR Research Data Repository for Knowledge Management. It is agriculture knowledge resources and information system for innovations. ICAR has received gold icon in Open Data Championship category for Digital Media Award 2020 for this portal. This is basically ICAR Research Data Management Guidelines. That is, whatever data we generate is the property of the ICAR. And that should be made available in any of these 6 repositories: experimental data, survey data, observational data, publication repository, technology repository, or geo portal, following the principle of FAIR, that is, data should be findable, it should be accessible, it should be interoperable, and it should be reusable. And there are many more things which we are doing. I will not be talking on that. As on date, we have links of 350, more than 350 ICT applications of this with more than 5 lakh page views. Today, we have more than 63,000. This is an old slide. 63,000 publications and more than 750 data sets from 107 institutes, which have more than 2 million downloads across the globe. These are also indexed in Google Scholar, Byfield Academic Search Engine, Directory of Open Access Repositories, and Guardian. We also have an interportal harvester, particularly for the students. We have more than 6 lakh metadata records for unified search from 36 repositories. It is a very good resource for literature search. Then technology repository, more than 1670. Today we have more than 2,700 videos, more than 355 audio, mobile apps at one place. Total mobile apps of ICAR have more than 4 lakh download by today. And there are many more things which are available, particularly ICAR GeoPortal, where we have more than 100 layers from 15 different themes. It also has points of crop residue burning, paddy residue burning since 2018 till date. All residue point burnings are available on this portal. You can go and see. Therefore, all these things are available there, and you can see all those whenever you feel free. I think just to share with you an example, particularly with the social scientists who are very interested nowadays in choice experiments. This is a new area which is coming up for the social scientists. Say we want to develop a chocolate. Okay, now 3 observable attributes of chocolate are its taste, which can have 2 different types, dark and milky, and then its softness, which can be soft or chewy, and it should have fruits or no fruits. Therefore, there are 3 factors, each at 2 levels. Therefore, total number of combinations I have 8. 8 types of chocolates can be prepared. Okay, now one choice set means which I have to give to the respondent for his or her views. Therefore, one choice set can consist of 2 products. Say, if we don't give more than 2 or 3, therefore, respondent is asked to choose one item from each of these choice sets. Therefore, out of 8, choose 2. These are 28 choice sets. Experiment can be conducted with only 4 choice sets, not more than that, each of size 2. Therefore, I again have 28 choose 4, that is 20,475 choice experiments, which would be best fit for the study of investigation, called design of choice experiments. But question is, we cannot have more than 4. Therefore, question is, out of 20,475, we have to select 4, and that is where statistics help us. Finally, I would like to quote top 10 regions to become a statistician, where deviation is considered as normal, because nobody wants to talk about deviation, but statisticians talk about mean deviation, standard deviation. We feel complete and sufficient. These are 2 properties of point estimators. We are mean lovers. Mean I have put in double quotes, leave you to interpret. Statisticians do it discretely and continuously, because we can handle both discrete as well as continuous random variables. We are right 95% of the time using confidence intervals. We can legally comment on someone's posterior distribution. We may not be normal, but we are okay. We can legally comment on someone's posterior distribution using Bayesian inference. We may not be normal, but we are transformable, because when data does not follow a normal distribution, we apply variance stabilizing transformations. We never had to say that we are certain, because level of significance is attached. We are honestly significantly different, and no one wants our jobs. And finally, a student defines statistics as strengthening technological advancement through implementing systematic techniques in contemporary sciences. This is what I wanted to share, and I am open to questions, suggestions.